All right, SOHCAHTOA. Today we're going to focus on the TOA part, or tangent. All right, before we get started though, you should do a quick calculator check. To do a calculator check, I just went ahead and picked tangent of 70. So on your calculator, you want to hit tan 70 or 70 tan, depending on which calculator you have. But you should get 2.74747744, something like that. If you're getting something different, it probably means your calculator is in radians, in which case we need to change it to degrees. So hopefully your teacher showed you how to do that in class already. But if you're not sure, email your teacher. But you definitely need to get that switched. All right. Nice tan. Using tangent to solve problems. So in this problem, I'm going to start with my theta, my reference angle of 62 degrees. I know that x is the opposite side. And then because the hypotenuse is over here, I know that 19 is the adjacent. And so when we go back to the idea of SOHCAHTOA, we know that we use tangent every time we have the opposite and the adjacent. So in this problem, we're going to be finding the opposite side, and we know the adjacent side. So the way we can set up this problem is tangent of the angle of theta, which in this case is 62 degrees. So tan 62 equals opposite over adjacent. So x over 19. All right, from here we're going to solve. And since we just got done with similar triangles and doing proportions, one way we can do this that's pretty slick is to just do a proportion and cross multiply. So change this into a fraction over 1. Cross multiply. X times 1 is x. And then tangent of 62 times 19. You got to be careful with how you do this in your calculator. We want to find tangent of 62, but then we're going to multiply that whole quantity by 19. What you can't do is don't multiply 62 times 19 to get a big number and then take the tangent of that. That won't work. So in my calculator, I'm going to find tan 62, which is about 1.88, and then I'm going to multiply the 1.88 times 19. So I get that x is about 35.7. So I go up here, my x is 35.7, which seems reasonable. This angle is bigger than that one, so this side should be longer than that one, and it is. All right, next example. I need to identify this side here, which is opposite. I need to identify this side here, which is adjacent. And you'll find that the problems we're doing today, we're always going to have the opposite and adjacent, and that's why we're going to use tangent. So I get tan of the angle, tangent 37, equals opposite over adjacent. So now when I cross multiply on this one, something that's going to be a little bit different is my x is not getting multiplied by 1, it is getting multiplied to the tangent of 37. So I'm going to write this as x times tan 37. And your teacher might show this a little bit differently, but the bottom line is we're multiplying the tangent of 37 times x. Okay, well that doesn't give me what x is, but how can I get x by itself? Well, because this is getting multiplied, I can simply divide by tan 37 on both sides. And this is not 17 divided by 37, right? It's 17 divided by the tangent of 37. So in my calculator, I'm going to do 17 divided by, and then tan 37, which gives me that x equals 22.6. And I would encourage you to double check some of these to make sure that your calculator is set up in such a way that you are getting these same answers. So again, that first one, 35.7 units, all right, and then the second one, 22.6 units. All right, so I went ahead and did the first two examples. Let's have you go ahead and try number 3. Let's see how you do. All right, well, let's take a look. We know that our opposite side is x. We know that 6 is our adjacent side. And we know that tangent equals opposite over adjacent. So I'm going to do tangent of the angle, which is 60 degrees, equals the opposite side, which was x, over the adjacent, which was 6. And then from here, I'm going to cross multiply. X equals 6 times tangent 60, which is not 6 times 60, right? We need to find the tangent of 60, which is about 1.73. Multiply that times 6, and I get that x equals approximately 10.4, right? 10.392, we'll round it to 10.4. So in this case, we do have units, so it's 10.4 feet. All right, let's go ahead and try number 4. Now number 4, your x is gonna be on bottom instead of on top. So let's see how you handle that. Go ahead and give it a try. All right, so we've got this side here is our opposite. X is our adjacent, all right? And we didn't use the hypotenuse at all, right? So we're using O and A, tangent. Tangent of 63 equals the opposite, which was 3, over the adjacent, which was x. I'm going to turn it into a proportion and cross multiply. So I get x times tan 63 equals 3 times 1. Right? And if you did it in the opposite order, that's fine. As long as one of your sides is x times tangent 63 and the other side is 3, you should be good. To undo the multiplication, we're going to divide by tan 63. And I plug that in my calculator. 3 divided by tan 63, 1.5, let's call it 1.5. So 1.5 yards. All right, hope you did okay with that. Moving on to number 5. Now we've got a word problem, but honestly, a lot of these problems, they give you the picture. So it's really not any different than any other problem. We're trying to find how far north did it travel. And I know north is up and down, so I'm trying to find this side here, which in relation to the 23 degrees, this is the opposite, this is the adjacent, right? And again, we know tangent equals opposite over adjacent. So tan of 23 degrees equals x over 45. Put this over 1. And you'll start to realize that if x is on the top, you're really just going to multiply your tangent times the number and you're done. But we can cross multiply just because that's what we've been doing. We're used to that. Tan 23 times 45. Again, make sure you do tangent of 23, not 23 times 45. So tan 23 is about 0.4. Times that by 45. And I get 19.1. So, question was in miles, so 19.1 miles. Okay, example number 6. We've got another word problem, but we have a diagram to go with it. We know that the light pole is 10 feet. We're trying to figure out how long the shadow is of this light post. And we know that the angle of elevation, or the angle from the end of the shadow to the top of the light post, is 58 degrees. So how would I set up this problem? What would my equation look like? That's right, we know that 10 is the opposite. We know that x is the adjacent. So we're going to do tan of 58 degrees equals 10 over x, opposite over adjacent. And then to solve it, we'll go ahead and cross multiply. 10 equals tan 58 times x, or x times tan 58. We want x by itself, so let's divide by tan 58. And at this point, we're just plugging in our calculator. 10 divided by the tangent of 58 degrees, which is 6.25. So the length of the shadow is 6.25 feet. Okay, so we can use tangent anytime we know one side of a right triangle, right? If we knew two sides of the right triangle and we were finding the third, we could just use Pythagorean theorem. But if we only have one side and we're trying to find a second, that's where trigonometry comes in to help us out. And as long as we have an angle and one side, we can find the missing side. What if instead we were given the two sides and we were asked to find the angle? Well, this is going to be a little bit different. It's still opposite and adjacent. So it's still going to have to do with tangent, but it's going to be a little bit different. So make sure you focus up here. All right, so if we have tangent of angle A equals 15 over 10, I'm just going to rewrite it here a little bit bigger, hopefully easier to see. Well, my goal is to get A by itself. I want to know what A is. So we use inverse operations, right? If it's multiplied, we divide. If it's added, we subtract. Those are inverses of each other. Well, the inverse of tangent is actually called inverse tangent. And you've maybe seen this on your calculator before, but you have sine, cosine, and tangent, but also you have sine with a -1, cosine with a -1, and tangent with a -1. And that's called your arctangent or inverse tangent. So I'm going to multiply each side by the inverse tangent, by tan -1. What happens when we multiply by tan of -1 is that cancels out tangent. So now I have A equals. Well, A equals 15 over 10 times the tangent of -1. Or the way I type it in my calculator is the inverse tangent, tan -1, arctangent, has a couple different names. But we're going to call it the inverse tangent. And we're going to take the inverse tangent of 15 over 10. And it's important that you put the 15 over 10 in parentheses so that you're taking the inverse tangent of this whole thing and not just 15. So in my calculator, to get inverse, I have to hit shift first. You might have to hit second. If you're using Desmos, your teacher will show you how to do that. But I'm going to do inverse tangent. So now my screen says tan -1. And then in parentheses, I'm going to put 15 over 10. Or I could have divided that and got 1.5 and done inverse tangent of 1.5. But I like just leaving the fraction there. It's going to be helpful when we have problems that are very decimal filled. But anyway, I do inverse tangent of 15 over 10, and I get 56.3 degrees. So again, in your calculator, you're going to do inverse tangent of parentheses 15 divided by 10. Now, side note, there are some calculators where you have to do this part first and then hit inverse tangent. So your calculator may be one of those where you have to go in opposite order. But the calculators we have at school, you do inverse tangent and then 15 over 10. So this angle here is 56.3 degrees. Or usually we'll round angles to the nearest whole degree. So I'd be fine calling this 56 degrees. All right. Calculate the ratio of the tangent of the indicated angle, then find the measure of the indicated angle. Long way of saying tangent B equals what over what? Well, it's going to be opposite over adjacent, which in this case they're the same numbers. So 2 over 2. But I want to find the angle measure. So angle is inverse. Angle's inverse, angle's inverse, angle's inverse. Anytime we're finding the angle, we're using the inverse of the trig function. So I'm going to end up calculating inverse tangent of 2 over 2. All right, I could show tan -1, tan -1 over here. I usually don't show that. I just go straight to, if I'm finding the angle, it's automatically the inverse trig function. And then I list out my opposite over adjacent. So tan -1, or inverse tangent, of 2 divided by 2, which is 1, right? But anyway, gives me 45 degrees. So the measure of angle B is 45 degrees. Calculators are pretty amazing. So is SOHCAHTOA. All right, this next one, 25 is opposite. 20 is adjacent. So how should we set this problem up? What should the equation look like? All right, very good. Because it's tangent, we got to use tan. But because we're finding the angle, we use inverse tangent. And then we do need to put the opposite on top. So 25 goes on top, 20 goes on the bottom. And inverse tangent of 25 divided by 20 is 51.3, or I'm just going to round that to 51 degrees. So angle C, 51 degrees. Okay, here's some more examples. Let's go ahead and have you try these. The one thing that I'm going to note before you start it though is make sure we know that in this case our theta is angle X. So that's the angle we're trying to find. Let's go ahead and do this first one. What is the measure of angle X? All right, so I know that my opposite is 5. I know that my adjacent is 9. So tangent of angle X is 5 over 9. Because we're finding the angle, it's going to be inverse. And I'm just going to plug the inverse tangent of 5 over 9 into my calculator. And I get that that angle is approximately 29 degrees. Okay, go ahead and try this one. Keep in mind we are starting from angle X. All right, so we've got tan of X. Opposite is 43, that goes on top. Adjacent is 30, that goes on the bottom. We're finding the angle, so we're going to use inverse tangent. And I'm going to find the inverse of 43 over 30. So inverse tan of 43 over 30. And hopefully you got about 55 degrees. Now if you got an answer that was above 90, that would make no sense, right? Because we already have 90 degrees and a triangle can only have 180. So an answer that's less than 90 definitely makes sense. If you're doing this wrong, you might be getting an answer that's like 0.043 or something like that. That would be a super, super small angle. That doesn't make much sense either. So always double check to see if your answer seems reasonable. And that definitely seems reasonable. All right, one more example before our final problem. We've got a moving truck with a ramp. And when the ramp is fully extended, it touches the ground 12 feet from the back of the truck. So the ramp is right here. So the back of the end of the ramp to the back of the truck is 12 feet. The height of the ramp is 2.5 feet, and we are trying to calculate the measure of the angle formed by the ramp and the ground. So that would be right here. We know that angle is inverse, and I'm using the opposite and adjacent. So right, today's all about tangent so far. So inverse tangent of 2.5 12. And I get an angle measure of 11.8 degrees. 11.8 degrees, or we could round that to 12 degrees. All right, so actually once you get the hang of this, it's pretty simple. Hopefully you guys are doing okay. All right, last problem. Determine the angle of elevation of the ski slope. So you're being asked to find this angle here. Well, if I do what I've been doing, opposite is here, adjacent is here. And let's go ahead and call this angle A for right now. So I would have tangent of A equals x over 4,689.2. Well, in order for me to use inverse tangent, I need to find what x is, right? And I might notice, okay, it's a right triangle, so I could do x squared plus this squared equals the hypotenuse squared and do all this math with these big crazy numbers just to get what x is. Or is there a simpler way? For this problem, yes, there is. Just because we've used tangent all day today does not mean that every problem is going to be a tangent problem. I might look at this and notice right away that this is my adjacent. This side is the hypotenuse. And which trig function, sine, cosine, or tangent, uses the adjacent and hypotenuse? Well, that's our ka, right, of so, ka, toa, which means cosine equals adjacent divided by hypotenuse. And if I know the adjacent is 4,689.2, and I know the hypotenuse, oops, I was about to write the word hypotenuse. I know the hypotenuse is 5,022.8. So if I already know those, and that's cosine, how can I find the measure of angle A? Well, since we're finding the angle, I can use the inverse cosine, which is going to be a lot shorter than using Pythagorean theorem to find this side and then plugging it into inverse tangent to calculate it. I can just simply go inverse cosine of 4689.2 divided by 5022.8. And I get that angle A is about 21 degrees. All right, hopefully I didn't lose you with that last problem. I put this problem on here to show that just because we did tangent for the lesson doesn't mean that every problem we get will be a tangent problem. It's going to depend on which sides we are given. So if we're given the adjacent and the hypotenuse, we are no longer going to use tangent, we're going to use cosine. If we were given the opposite and the hypotenuse, we would use sine. And that's what we'll be doing tomorrow, is figuring out which one would be the correct trig function to use and then do the calculations. But for today, if we have opposite and adjacent, if we're finding a side length, you use regular tangent. But if you're finding an angle measure, you use inverse tangent. So hopefully you guys did okay with this. You're gonna do great, I know it. Go Titans.